Our next unit is logarithms and exponential functions, and we're starting with taking a look at graphs of exponentials. The first thing that you need to understand about exponentials is that there are actually a ton of different parent functions. The parent function depends on the base of the exponential. So if you look at our first example, the base is what's being raised to the power. So this piece right here, the 2, is the base. If the base changes, then the parent function will change as well. But the most basic form of an exponential graph is y equals some number, the base, to the x power. As we add in transformations where we multiply or add or subtract to the x or to the function, that's when we'll get our transformations. So starting off with the domain of the function, the question is, what numbers can you use as an exponent, or what numbers can you raise 2 to the power of? Well, we can raise 2 to positive numbers, 2 squared, 2 cubed, etc. We can raise 2 to a 0 power, and we can also raise 2 to negative numbers, 2 to the negative 1, etc. So the domain is all real numbers. For the range, we ask ourselves, what numbers do we get out of an exponential function? Well, when we raise 2 to the 0 power, we get 1. 2 to the first power is 2. 2 squared is 4, so we're getting positive numbers. What happens when we raise 2 to a negative number? So let's think about that. If we have 2 to the negative 1 power, remember, a negative exponent means you flip it to the denominator and the power becomes positive, so we get 1/2. Notice that we are not multiplying our base by a negative. We are flipping it to make the exponent become positive. So we actually do not get any negative values out of an exponential. We also cannot get 0 out of an exponential. So our range is y is greater than 0, not greater than or equal to y is strictly greater than 0. X-intercepts are where the function equals 0. We just talked about our range, how we cannot get 0 out of an exponential function. So we have no x-intercepts. Y-intercept is what happens when you substitute 0 for x. So 2 to the 0 power gives us 1. So our y-intercept is 0, 1. And exponential functions have an asymptote. Remember, that is a line that the graph approaches but does not cross. For the parent function of all exponentials, the asymptote is at y equals 0. So if you think about that, again, it's that value that x will approach. The bigger the exponent is if it's negative. So think about that 2 to the negative 1, we got 1/2. 2 to the negative 2 would be 1 over 2 squared, which is 1/4. The higher that power as a negative, the smaller the answer. So we're getting closer and closer and closer to 0, even though our answer doesn't ever equal 0. So let's take a look at the graph of our function. Plotting our y-intercept, we have 0, 1. And then I'm quickly going to run through a t-chart for this one, so I'm going to talk through the t-chart instead of writing it down. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. And 2 to the fourth power is 16, which won't fit on our graph. Now we're going to take a look at plotting some of those negative exponents. We got 2 to the negative 1 was 1/2. 2 to the negative 2 we looked at and we got 1/4. 2 to the negative 3 is 1 over 2 cubed, which is 1/8. So as you can see, we're getting closer and closer to that asymptote of y equals 0. This is an example of an exponential growth. As you can see, as the x values get bigger, our y values get bigger. Later on in this unit, we'll see an example of an exponential decay, where it looks kind of like it's flipped across the y-axis.